Hello, this is Josh Cortez. This is the assignment video for homework 7, class CSC412. This is a machine learning project, or I guess homework assignment. So first of all, we're just going to go ahead and clear all outputs, and I'm just going to go through, run through them, and explain what they're doing. So this right here is obviously mounting your Google Drive to access files. This is just connecting it. It's going to say that I already am connected because I was testing it earlier and just from using or following the videos. And here for the CPs, copying the dataset and a helper Python file from the drive. So I'm pretty much just connecting it to or showing it the path to iris data, which is what our dataset is. And pip just shows all of our stuff, which I mean I guess I didn't really need. Yeah, it's a lot actually, so I'll just go ahead and hide that. Right here we're importing all of our stuff, so nothing too crazy. It's just importing the pandas and NumPy for basic, or not basic, for data manipulation, or not manipulation, working with the data. And here is the math for just any basic arithmetic or whatever we need to do. And sklearn is the machine learning thing that or thing that we're using. So, or the library. Sorry, I shouldn't say thing. It's one of the machine learning tools, and this is just what we use to plot out the stuff later. And yeah, this is just the pandas version, and this is where it reads that data set. And I ran it, right? I'll just run it again. And this just gives us a quick summary of the numerical columns. So let's see here. Yep, we see there are 150 total samples, and the four measurements are sepal length, sepal width, petal length, and petal width. Right here. This is the non-numerical data. So we chose class from the video, so you see that there are three different classes: the setosa, versicular, 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 virginica. Those are the three different ones, and here we are pretty much changing them or converting them into integers. So 0 would be the setosa, 1 would be versicular, and 2 is virginica. I'm not sure if I'm pronouncing versicular correctly there, but it's alright. And this right here, this is going to have no output just because we have it commented out. So we just move on from that one then. And the randomized cell, so we'll see the original file sorted by species. We'll shuffle the rows randomly. This also will have no output, but I guess we can just run this and then this. But we didn't really need to run this because it was commented out. And right here, we have two functions here. So the first one pulls the four measurement columns and also creates a fifth one, the sepal area right here, and which is just length times width. And the second one just pulls out the class label column. Run that. And this one also has no output, so this is just setting our split parameters. So 80% of the data will go to training and 20% will go to testing. And we're also getting 5 folds for the cross-validation, which we use later. Just run that. Now here we separate the I can't think. No, I'm sorry. We're initializing everything here. So all this stuff here is just what we used for later on in the video. And this is our sanity check. This is just where we can see that the 150 total examples split into 120 for training and 30% or 30 for testing. The feature also states, or the feature stats. My goodness, the feature stats for both sets are printed. So here we go. The mean values are close to between training and validation, which tells us the shuffle worked for the randomization. And this is the scalar, so we can just go ahead and run that again. Here we standardize all the feature values, so each column that has a mean near 0 and a standard deviation near 1. This helps the model perform more consistently, and you can see the training data output looks about right here. So yeah. to this initialization, more variable initialization. So we can just, I guess we can just skip over that for now. And the actual training of the data. So here you train the two models. First is the logistic regression, and second one is the vector um, support vector classifier. For each one, we call the dot fit with the training features and labels, and then add the training model to our list. The output shows the parameters. Hold on, let's see here. There we go. Wait. Yeah, that's fine. And it just shows the each model was configured with, the parameters each model was configured with. And then we can make our prediction here. So as you can see, everything here is actually pretty good. I think it's 1-to-1 actually. I don't think there's any failures or errors. Let's see here, and then generate that confusion matrix. Again, there's no output for that one yet. And then we can run the accuracy score. So also don't mind these right here. This is just a warning because of the package that I have installed. Here we print the basic accuracy for each model. For each one, you get the overall score on the 80-20 split. 80-20 split, sorry, a breakdown by individual classes, and then the cross-validation score, which tests the model across 5 different splits of the data for a more reliable estimate. And here we go. Oh, actually, I guess we can make sure that. So run everything before, and then run that. So here, each grid shows how the model performed per class. The number on the diagonals are correct predictions, and anything off the diagonal is a mistake. Both models land mostly on the diagonal, except for obviously one here. And yeah, just means they're classifying the species accurately. So I'd say it's a pretty good machine learning model. Thank you for listening, and let me go ahead and stop there.